Hello everyone. In the last lecture we discussed definition of limit for multivariable function. In this lecture we are going to solve some example by using Epsilon-delta definition of limit of multivariable function. Before going to example, first of all we revise the definition of limit. Now let f of xy is defined in deleted neighborhood of point x0, y0 of domain D, which is subset of R2. Then we say that f of xy tends to L as L is a limit as xy tends to x0, y0. If for any or given epsilons, which is a positive real number, if there exists delta greater than 0 such that difference between f of xy and L is less than epsilons if in terms of circular neighborhood 0 is less than square root of x minus x0 whole square plus y minus y0 whole square is less than delta, or in terms of square neighborhood 0 is less than mod of x minus x0 is less than delta and 0 is less than y minus y0 is less than delta. And we write this one as limit as xy tends to x0, y0 of f of xy is equal to L. So this is nothing but Epsilon-delta definition of limit of a function of two variables. Now we solve some examples and we find the limit by using Epsilon-delta definition. So go to the example. Let f of xy is equal to x square plus y square and take epsilon is equal to 0.01 and find delta. Find delta greater than 0 if exists by using this Epsilon-delta definition. So here function is given f of xy. What is f of 0, 0? So obviously it is 0. So if we are to find limit at the point 0, 0, then yes, L should be 0. Okay. So to find limit of f of xy at origin, we try to find f of 0, 0, so that is equal to 0 square plus 0 square is equal to 0. Okay, so that is equal to L. So what is our Epsilon-delta definition? We find out difference between f of xy and L. So f of xy is over here, it is mod of x square plus y square minus 0. So that is nothing but mod of x square plus y square. So mod of x square plus y square is nothing but x square plus y square. Okay. Now this x square plus y square, now recall the definition of circular neighborhood of point. So in that case, deleted circular neighborhood of point. So in that case we have 0 is less than square root of x square plus y square is less than delta. Okay. So square root of x square plus y square is less than delta means x square plus y square is less than delta square. So obviously this will be less than delta square because of this reason. Okay. And it is equal to say epsilon. It is equal to epsilon. So thus what I am getting? Thus mod of x square plus y square minus 0 is less than epsilon, where there exists delta is equal to, what is delta? Delta square is equal to epsilon. So delta is equal to square root of epsilon, which is also positive square root. So that's why it is greater than 0. So thus for this epsilon I am getting delta. Okay. Such that it satisfies epsilon's delta definition of limit. Now take epsilon equal to, what is epsilon? 0.01. So therefore delta is equal to square root of epsilon. So that is square root of 0.01, and that is nothing but 0.1. So I am getting delta equal to 0.1 for epsilon equal to 0.01. Okay. So thus for any epsilon value we are getting delta. So therefore limit of the function exists at the origin and is equal to 0. Now we'll take one more example, simple example, in which f of xy is equal to, say, product xy. And I'll take, let epsilon equal to, say, 0.1. And we have to find again delta if it exists. Now to find again limit of the function at origin, we try to find f of 0, 0. So that is equal to again 0 into 0. So that is equal to 0. Now consider difference between f of xy and L. So that is equal to this product xy minus 0. So that is nothing but this product xy. Mod of xy. So that is equal to mod of x into mod of y. Now, instead of this circular neighborhood of a point, we use here square neighborhood. So what is the square neighborhood of the origin? Square neighborhood of origin. So 0 is less than mod of, instead of x minus x0, we have mod of x minus 0. So that is mod of x is less than delta, and 0 is less than mod y is less than delta. So I'll drop this part. So we use this square neighborhood definition, and using it I'll get here mod of x is less than delta, mod of y is also less than delta. So that is equal to delta square, and say that is equal to epsilon. Okay. So again delta is equal to square root of epsilon. Okay, delta is equal to square root of epsilon. So therefore, so for epsilon is equal to 0.1. So delta is equal to square root of epsilon, that is square root of 0.1, and we can find it. Actually this number, it is not a complete square, 0.1, but we can easily find it by using calci also, and it is greater than 0. So thus for epsilon is equal to 0.1, there exists delta is equal to square root of 0.1, which is greater than 0, such that difference between xy and 0 is less than epsilon whenever 0 is less than mod x is less than delta, and 0 is less than mod y is less than delta. And in short, so therefore we say that limit as xy tends to 0, 0 of f of xy, that is nothing but xy, is equal to 0. So limit of this function is 0 by using epsilon's delta definition. For any epsilons, we are able to find this delta. Okay. Now one more example. Now one more important thing, this definition of limit, this epsilon-delta definition of limit is also called simultaneous definition of limit, or it is, this limit value is called simultaneous limit. Okay, we go for example. Let f of xy is equal to x plus y divided by 2 plus cos x, and take epsilon is equal to 0.02, and we have to find here limit or delta value. We have to find delta taking L as again 0. Okay, why L should be 0? So f of xy, that is, suppose it is equal to f of 0, 0. So I will get here 0 plus 0 divided by 2 plus cos of 0. So it is nothing but 0. Okay, so it is equal to L. I should write here x0 y0. F of x0 y0 is equal to f of 0, 0 is equal to 0. So take L is equal to 0. So we have to, in short, we have to find limit. We have to show that limit of the function at the origin is equal to 0 by using epsilon-delta definition. Now, again consider mod of f of xy minus L. So that is x plus y divided by 2 plus cos x minus 0. Now, before going to this step, we have to do some job. So that is, we know that we have this minus 1 is less than or equal to cos of x is less than or equal to 1. Okay, so we add 2. So 2 minus 1 is 1 is less than or equal to 2 plus cos of x is less than or equal to 3. Now take reciprocal. I will get here 1 upon 1, or I will write from this side. So 1 by 3 is less than or equal to 1 upon 2 plus cos of x is less than or equal to 1. So multiply by x plus y. We may multiply. So I will get here x plus y by 3 is less than or equal to x plus y divided by 2 plus cos of x is less than or equal to x plus y. So, if I take modulus also, I will get here mod of x plus y by 3 is less than or equal to mod of this one is less than or equal to x plus y. So, we are over here. So, use this part. So, this mod of x plus y divided by 2 plus cos x is less than or equal to mod of x plus y. So, I will write over here using this fact, it is less than or equal to mod of x plus y. Okay. By using triangle inequality, it is less than or equal to mod x plus mod y. Also, by square neighborhood definition, it is less than, yes, it is less than delta, because 0 is less than, mod x is less than delta. So, it is less than delta plus this mod y is also less than delta. So, that is equal to 2 delta, and that is equal to epsilon, same. Call this 2 delta as epsilon. Okay. Now if epsilon is equal to 0.02, what will be delta value? I will drop this part, and for epsilon is equal to 0.02, we have mod of x plus y divided by 2 plus cos x minus 0 is less than the 0.02, where delta is equal to epsilon by 2. So that is equal to 0.02 by 2 is equal to 0.01. So for epsilon is equal to 0.02, there exists delta is equal to 0.01. So thus for any epsilon there exists delta. So we can say, in short, for every epsilon there exists a limit for the function, and limit value is 0. So limit exists. Now one more concept is there, iterated limit. So what is that iterated limit? It is different from the simultaneous limit. So just illustrate it. What is iterated limit? We try to find iterated limit. This iterated limit is also called repeated limit. So iterated limit, it is nothing but repeated limit. In simultaneous limit, we take limit of f of x, y when both x and y simultaneously tends to x0, y0. And if this limit value is finite, then we finite and say L, then we say that limit, simultaneous limit of f of x, y is equal to L. But in case of iterated limit, we take limit of f of x, y, say first of all with respect to x, so when x tends to x0, okay, and if it is equal to phi of y, okay, if it is equal to phi of y, then we take limit when y tends to y0 of this phi of y, and if that is equal to L1, then we say that limit y tends to y0 of phi of y is nothing but limit x tends to x0 of f of xy is equal to L1. Okay, these iterated limits can be of two types. Obviously, in the same way, if limit when y tends to y0 of f of xy is equal to suppose psi of x, okay, and limit x tends to x0 of psi of x is equal to say L2, where L2 is some finite real number, then we say that this repeated limit x tends to x0 of psi of x, that is limit y tends to y0 of f of xy is equal to L2. So L2 is iterated, one more iterated limit of the function f of xy. This both iterated limit may exist, may not exist, may be equal, may not be equal. Okay, so they are totally independent. And there is also no relation between simultaneous limit and iterated limit. Sometimes both iterated limit may exist, but simultaneous limit may not exist. We'll take one example. Find both iterated and simultaneous limit of simultaneous and both iterated limit of f of xy is equal to y plus x into sine of 1 by y if y is not equal to 0 and is equal to 0 if y equal to 0 or f of x0 is equal to 0. So, first of all we try to find iterated limit. Okay. So, first of all consider limit of the f of xy when x tends to 0. Okay. So, that is nothing but limit when x tends to 0 of y plus x into sine of 1 by x. Now x and y are independent. So when x tends to 0, as y is independent, we will keep as it is. So it will be y plus x is 0. So 0 into sine of 1 by y. So that is equal to y. So I am getting this is phi of y is equal to y. Take limit of y. take limit of this phi of y is equal to y as y tends to 0. So consider limit when y tends to 0, limit when x tends to 0 of f of xy is nothing but y plus x into sine of 1 by y. So that is equal to limit when y tends to 0, this limit part we know that it is equal to y and that is equal to 0. So therefore this iterated limit exists. We may say iterated limit of first kind exists, and now we try to find iterated limit of second kind. So now consider limit when y tends to 0 of f of x. So that is equal to limit when y tends to 0 of y plus x into sine of 1 by y. So that is equal to, now over here I am getting 0. Over here I will find plus x into limit y tends to 0 of 1 by y, sine of 1 by y. Now from the function of single variable, we know that limit of this function of single variable, limit when y tends to 0 of sine of 1 by y does not exist. It have multiple value. What is the graph? So look at the graph. At the origin, this sine of 1 by x function here fluctuates like this one. So initially it is like this one. And at origin, it fluctuates like this one. So at the origin it has multiple values, and we know that from the calculus of single variable, limit of the function, if it exists, then always it is unique. Same result is true for multivariable function also. If limit exists, it should be unique. So for this one we get multiple values for limit, so therefore we say that limit does not exist. So therefore it does not exist, which does not exist. So one kind of iterated limit exists, it's equal to 0, and another kind of iterated limit does not exist. Now what about the simultaneous limit? We go for the simultaneous limit of the same function. So for simultaneous limit, we use Epsilon-delta definition. We consider modulus of f of xy minus L. Okay, L we choose as 0. Okay, f of x0 is defined as 0, so that's why 0. So that is equal to mod of y plus x into sine of 1 by y minus 0. Actually we are assuming L means there exists some L, and we try to find corresponding delta for any epsilons. Okay, we are assuming here the limit, simultaneous limit of this function exists, and that is equal to 0. So what's our job? For any epsilons, we have to just find there, to show that there exists some delta. So consider this part. So that is equal to, now minus 0, obviously it will go off, and we apply triangle inequality. It is less than or equal to mod y plus mod of x into sine of 1 by y. Okay, so this is mod AB. Okay, that is equal to mod A into mod B. So I can write it is equal to mod y. This previous step is equal to mod y plus mod x into mod of sine of 1 by y, and we know that for any x, mod of sine x is always less than or equal to 1. So I'll write this term is less than or equal to 1. So that's why we'll get it is equal to mod y plus mod x. Now we, by square neighborhood definition, we know that mod y is less than delta at origin, and mod x is less than delta. So therefore I write it is less than delta plus delta is 2 delta. Okay, since 0 is less than, mod x is less than delta, 0 is less than, mod y is less than delta, and it is equal to, say, epsilons. So thus for any epsilons greater than 0, there exists delta. Delta is equal to epsilons by 2, and it is also positive because epsilons is positive, such that it satisfies the definition of limit, that is mod of y plus x into sine of 1 by y minus 0 is less than epsilon for 0 is less than mod x is less than delta, 0 is less than mod y is less than delta. So therefore, simultaneous limit of this function exists. One of the iterated limit also exists, but another iterated limit does not exist. So there is no any relationship between simultaneous limit and iterated limit. But one fact is that this formulae for iterated limit can be used to find simultaneous limit.